Hello and welcome to more equations. We're going to be working through section 2.3, and example 1 in my notes here is going to correspond with example 1 in the notes in the book. You are expected to read the book. This is meant to complement the book. These are different problems to help you out to gain a better understanding of the chapter. We're going to look at some tricks that can be used in solving some equations like we were solving yesterday, some to make them simpler, and some special cases that might come up as you're solving. First example we're looking at today is a fraction problem. You'll notice there are fractions all over this guy. Fractions a lot of the times can just give you a headache. So I'm going to teach you a little trick to make it a little simpler. What I'm going to do is I'm going to take a look at all of these denominators, 3, 2, and 6. And I look at those denominators, and we need to find a number that all three of those numbers divide into evenly, the least common multiple. A little bit of inspection, you'll notice they all go evenly into 6. So what I'm going to do is I'm going to multiply both sides of the equation by that least common multiple, 6. Now we have to distribute through parentheses. So the 6 is going to distribute only onto the numerators, and we'll have 6x over 3 plus 6 over 2 equals, distributing the 6 on the other side, 6x over 6 minus 6 times 2. And what's really neat here is I can look at all of these fractions that are left now, and I can reduce each fraction to a number. 6 divided by 3 is 2, so I have 2x. 6 divided by 2 is 3, plus 3. And 6 divided by 6 is 1, so we just have 1x. Now I can solve this like we solved equations yesterday. Move over the smallest x to get all the x's together. Simplify by combining like terms. And finally, to get rid of the plus 3, we should be really quick to subtract 3. And I'm left with x equals a negative 15. That's a nice shortcut with fractions. Multiply by the least common multiple. What about with decimals? Decimals can get a little hairy if we don't want to work with them. A trick we can do is we can multiply by a power of 10. 10 has 1 0. 100 has 2 zeros. 1,000 has 3 zeros. What we do is we're going to look at these decimals and which decimal has the most numbers after the decimal point. Well, right in the middle you'll see a 2.08. There's 2 decimals. So we're going to put 2 zeros and multiply by 100. 2 zeros. What that's going to do is it's going to move the decimal point 2 places. Very important we multiply on both sides of the equation to always maintain that balance. 0.4 times 100 is 40. 2.08 becomes 208. And 1.2 becomes 120. Now this solves exactly like yesterday's assignment. First thing we get rid of, working backwards through order of operations, is any adding and subtracting. Get rid of that plus 208 by subtracting 208. And finally, to get rid of 40 times x, we divide by 40. X equals negative 2.2. Skipping up to an example like on example 5 in the book, here we've got 2x minus 18 equals 2 times x minus 9. Well, nothing special about this one, I guess. We need to get rid of the parentheses first, as always. Distribute the 2 through the parentheses. We end up with this. Well, we've got x's on both sides, so we need to move the x's to the same side. Neither one's smaller, they're both the same. Well, let's just subtract the 2x off the left and see what happens. Doing the same thing to both sides, when we subtract, we end up with negative 18 equals negative 18. Well, now what? Is negative 18 the answer? No, negative 18 is not the answer. This does not say x equals something. This says negative 18 equals negative 18. Well, how often does negative 18 equal negative 18? Always. When we get an equation that's always true, we call it an identity. An identity is true for all numbers. And so if I ask for the answers, you can tell me all real numbers work for the answer. No matter what number I put into x, this equation will always work. Let's try another one. Boy, this one looks like a beast, but we can handle it because we've got a system to solve equations. First, we get rid of the parentheses using the distributive property. Now the left side looks like it's got a lot of stuff going on. Let's combine like terms. 5m minus m is negative m, and negative 5 minus 18 is negative 23. Now we can solve this. We have m's on both sides, so we're going to combine them together. The opposite of a minus m is a plus m. And when I do that, we get negative 23 equals 4. Well, that's weird. How often does negative 23 equal 4? Never. When you get something that never works, we call the system inconsistent. That means there are no solutions. And a lot of the times you'll see mathematicians write this little circle with a slash through it. That simply means inconsistent and no solutions. That means no matter what number I pick for m in this equation, it will never, ever work. There's no solution. As always, this was not a detailed review. More examples are found in the book. You are expected to read the book to cover all the examples given. The homework assignment is on page 108. We're going to work through numbers 7 through 95. I need you to do every other odd. So start with 7, skip 9, do 11, skip 13, and so on. As always, this week's homework is due Tuesday, September 30th by 3 p.m.